Analyze the graphs below. All right, to analyze a graph like this, there are a couple of things you should think about, or maybe at least 3 things you should think about. I would say you want to think about the domain of the function, you want to think about the intercepts of the function, and you want to think about the asymptotes for the function. You can also throw in the range there if you want. So I would say domain, range, intercept, and asymptote are basically the things to consider. So let's talk about the domain for function a. So if we look at the domain, it looks like these red lines are representing the asymptotes of the graph, right? You can kind of see that there are no points along those vertical red lines, and that's because those would be vertical asymptotes for the function. It looks like those places occur on the x-axis at -2 and +2, right? So in other words, it looks like this is happening over here and over here. So we're going to say that the domain appears to be from -∞ up to -2. Don't include -2, but pick up again from -2 up until 2. It looks like we have parts of the graph there, but then we have another gap, right? And then we pick up again after 2 and go up to +∞. So it looks like that would be the domain for graph A. The range for graph A can be seen by also looking at the graph. It looks like we have points extending from 0 up to +∞ along the y-axis, right? So in other words, from here all the way up, we have points. So it looks like the positive part and the 0 part of the y-axis is covered. But what about the negative part of things, right? Well, it looks like from -∞ up to this horizontal asymptote that's highlighted in red here, we have points, but we don't have any points in this kind of nether region between the two horizontal lines there, one being the x-axis and the other being that red horizontal asymptote. All right, so let's go ahead and say that it appears that the range goes from -∞, right, all the way up until -1 on the y-axis, right? At -1 is where you find this asymptote. So we're going to round the bracket at -1, then we'll pick up again at 0, but we're going to put a square bracket here because we're saying we want to include 0 because there is a point, it looks like, right here at the origin on the y-axis. So then we go all the way up to +∞ from there. So that appears to be the range. All right, from there, let's talk about intercepts. Well, it doesn't look like we have any intercepts on this graph except for perhaps the x and y intercept, right? That occurs at the origin. So it looks like we have the point 0, 0 as both an x-intercept and a y-intercept. Oftentimes the intercepts are separate points. In this case, they are the same. All right, for the asymptotes, you mainly need to remember how to express these asymptotes, right? So when you look at the horizontal asymptote, right, the equation is always going to have to be y equals something, right? So in this case, it looks like that horizontal red line is at y equals -1. So that would be the horizontal asymptote. If you're talking about the vertical asymptote for this equation, then you're talking about places where x is equal to something. So where does the dotted red line occur on the left? It looks like at -2. So we have a vertical asymptote at x equals -2. And then there's another one at x is equal to +2. And again, those are the places we identified in our domain where the graph seems to not have any points along the x-axis. All right, so let's do the same thing for graph B that we did for graph A. Let's first identify the domain. It looks like the only vertical asymptotes we have, or any concerns we have, are really with x equals 0, right? You can see there's a vertical asymptote indicated here in red at x equals 0 on the x-axis. So we can say that the domain is all real numbers except for 0. In other words, it's from -∞ up to 0. Use parentheses around those terms, then union from 0 to +∞, right? So again, we're excluding 0, so we use the rounded parentheses there to say that 0 is not part of the domain. All right, let's take a look at the range next. So the range will basically be, it appears that there are no points in this region, right, along the y-axis. So it looks like at 1, 2, there's this point here, right? So this point appears to occur at 1, 2, which means 2 on the y-axis. And this point here seems to occur at -1, -2. So that means -2 on the y-axis. So it appears that there are no points on the y-axis between -2 and 2. So we're going to say that the range goes from -∞, right, all the way up to -2. There are points there. And then there seem to be points from 2 to +∞. But there doesn't seem to be any points outside of those areas, so we're going to say that if you add those two sets together, or you union those two sets, you end up with the entire range for the function. All right, then we're going to go after the intercepts, if there are any. And because of the asymptote that exists at x equals 0, I don't think there's any y asymptotes, right? Because this asymptote here, that runs along the y-axis is preventing the graph from touching that. So there will be no y-intercepts. It also appears that there are no x-intercepts, because in order for there to be an x-intercept, the y would have to be 0, and you can tell that the range has no what? No zeros in it, right? The set that makes up the range for the y-axis doesn't include 0. In order to find an x-intercept, you have to set y equal to 0. Well, there are no points at y equals 0, so there's no x-intercept. So I would say this graph has no intercepts, right? All right, then lastly, we're going to talk about the asymptotes, right? So as we mentioned before, there's a vertical asymptote, and that asymptote is occurring where x is equal to 0, right? And then we have something called a slant asymptote, or you might call it an oblique asymptote, right? So oblique asymptote, or some people call it a slant asymptote. That type of asymptote is basically sort of on a diagonal line. In this case, the equation for that appears to be y is equal to x. And why do I say y equals to x? Because if you look at the point they have illustrated, they say that the point is 1, 1. That means when x is 1, y is 1. So that indicates that, again, we're on this diagonal line that is formed by graphing all the places where y and x are the same. That's a very common oblique asymptote or slant asymptote. So we're going to say that that red dotted line has the equation y is equal to x. All right, and that covers it. We have the domain, the range, the intercepts, and the asymptotes for each of these graphs.